in a previous video, I was explaining how to use geometric mean to solve for unknowns with right triangles, and my program was acting up, so I'm just going to kind of pick up where I left off. So some of the context may be missing, but we're looking at when we have a right triangle and we have an altitude going from the hypotenuse to the vertex of the right angle, we create similar triangles, and the geometric mean helps us to match up the ratios of corresponding sides to solve for unknowns. One of the geometric means was the altitude, meaning it was the value in between the segment lengths of the hypotenuse created by the altitude. But the legs are also geometric means. They're geometric means of the adjacent segment of the hypotenuse and the length of the entire hypotenuse. When I say the adjacent segment, I mean the segment that's adjacent to the leg that we're referring to as a geometric mean. So this leg is a geometric mean of this segment length and the entire hypotenuse. This leg is a geometric mean of this segment length and the length of the entire hypotenuse. So we want to solve for B in this example here. So again, I'm going to use proportions, recognizing that I'm dealing with similar triangles because of this altitude. And I know that my geometric mean, whatever it is, goes in both spots of the diagonal in a proportion. So I always choose this diagonal here. So my geometric mean, which is I recognize as a leg, as the length of the leg, is going to go here and here. And then what it's the geometric mean of goes in the other two spots. In this case, it's the geometric mean of B, this segment length, and the length of the entire hypotenuse. So if I want to solve for B, I'm just going to cross multiply and divide, and I get approximately 4.2. Okay. If I was given this leg, and let's call this segment length here A, and this leg being, let's just say it was 15 units long, then I would have 15 as my geometric mean, and it's the geometric mean of this segment length, we'll call that A, and 24. Now, what about when we have that was a case where the leg was known, and this is a case where it is not known. It's the same thing though. I recognize my legs as geometric means of the adjacent segment of the hypotenuse and the entire hypotenuse. So x is my geometric mean. My geometric mean goes in both spots of the same diagonal, and what it's the geometric mean of goes in the other two spots. In this case, that would be 9, and the length of the entire hypotenuse is 20. So I have x times x, which is x squared. 9 times 20 is 180. I don't want x, I want x squared, so I take the square root of both sides. So x would be the square root of 180. And we can break that down to, let's see, the square root of 36 is a perfect square. That's a 3 times the square root of 5. Square root of 36 times the square root of 5 is the square root of 180. I did that because 36 is a perfect square, so I end up with 6 square roots of 5. Okay, so I hope that helps you. Watch it again if you need to, if I went too fast.